Awesome. So everyone, welcome to RC Talks. Uh, I am Alok. I've been working as a cloud consultant in Rapid Circle for 5 years. And here I have the pleasure of presenting today's session with Bhushan. And Bhushan has been a senior cloud consultant in Rapid Circle for 8 years. And would you like to introduce yourself?
Yeah, no, thanks, Alok. Yeah, my name is Bhushan, working as a cloud consultant here in Rapid Circle. Have been working with this amazing organization for more than 6 years now. So thanks everyone again for joining this. So Alok, I'll hand it over to you to explain the intent of session in general.
Yeah, so the intent of today's session is to first cover some basic blocks of Azure networking. And then later we will dive into some insights of ExpressRoute, which is generally an unknown territory for most cloud developers. And we will also talk about some customer scenarios that we have worked with in Rapid Circles. So first, the basic building blocks of Azure networking. So the first basic building block of networking is a virtual network. So what is a virtual network? Consider this example of a housing society with many individual houses. Uh, every society has a defined perimeter of or a defined boundary around it to isolate it from the rest of the world. So similarly, your virtual network is nothing but a group of devices or a group of workloads which have a well-defined boundary and they are separated from the rest of the networks. So that's nothing but a virtual network.
Right. So Alok, then speaking of virtual networks, so there is always this term that pops up, which is CIDR, and then there is this numbering 10.0 dot something, and then slash, there is a number. So how do you explain that? How do you look at that?
Yeah, so that's a good question. So first of all, continuing our analogy, every house has an address. So your devices in your virtual network will have an IP address, and every housing society has a range of addresses that it can have. Okay. Similarly, your virtual network will have a well-defined and finite range of IP addresses. Now, how do you represent that range in a standard notation? So that's where CIDR notation comes in. So the /24 /16 that you were talking about, that is nothing but, as you can see, an IP address, IPv4, is a 32-bit number. It's divided into 4 octets, so 4 8-bit numbers. When I say /24, it means the first 3 octets are fixed. So that's the blue part. And all the usable IPs I can generate by varying the last octet. So similarly, /16, the first 2 octets are fixed and the last 2 octets can be varied from 0 up to 255.
Okay, so no, that's pretty helpful and makes it quite clear. Alok, then extending this further, I've always heard these terms like, okay, can you create the VNet and then these many subnets? So I understand that subnet could be that part within the virtual network. But then what is the subnetting concept as in general and what value it really brings to the table?
So in layman's terms, a subnet is basically a smaller division of a virtual network. And why do we need it? See, every uh, housing society, continuing our analogy, uh, has to have different zones, and each zone has a different purpose, and each zone has a different rules. Okay, so consider there's a residential zone, there's a commercial zone, there's a clubhouse. Okay, and all these different zones have to be separate. They must have well-defined boundary, and they will have their own rules as to who can enter and what can be done there. For example, you can't party in the residential zone, but in the clubhouse only. So here you can see our virtual network, which is of /16 range, is divided into two subnets, which are of /24 range, so smaller range. Okay, so one is data tier, one is web tier. So an example in this could be that your web application servers are in your web tier subnet and your database virtual machines are in data tier subnet. So that's where subnetting comes into picture.
Right. So I understand this concept now. So what it means is if you can define the smaller perimeter for your subsections within that virtual network,
Yeah.
so then it can protect you. And then there is no overlap between different security policies or principles that probably you want to apply only to that particular section, right? So that's how it gives you a kind of enhanced sense of security, right? In that case.
Correct.
Okay. All right. And then but then how do you enforce this? How do you enforce that? Okay, I want to now control the security for this particular subnet. So in Azure's term, and continuing with the same analogy that we are talking about of the building and the society and the houses, how do you enforce these rules?
Yeah.
What can help us there?
Yeah, so that's a good question. The rules that Bhushan is talking about is who can enter a particular subnet and who can exit a particular subnet or a zone. So suppose we keep a security guard in front of each zone who has a register which has a list of entries where as to who is allowed into that zone. Okay, so that's where the concept of network security group comes into picture in Azure. So network security group is associated with your subnet. So that's your security guard sitting in front of your zone, enforcing certain rules.
By looking into that register, basically.
Yes.
Okay.
Yes. Now, in this diagram, you can see that next to the subnet, there is an NSG. Also, just below the VM, there is a green icon called as NIC or Network Interface Card, and an NSG is associated with that also. So that is where, first of all, touching upon NIC, and NIC is a network interface card. Yeah, any device which has an NIC has the ability to talk to the network or has a networking ability. When I associate rules to that NIC, it means that I have a security guard in front of my personal house as well. Okay, so there are separate set of rules that apply to that VM only, and then there are separate set of rule that apply to the whole zone.
Right. Okay. And then you can also override certain rules based on who processes those rules, right? So it could be that personal security guard that you have right in front of your house versus the zonal security guard, which is controlling the traffic to that particular subnet. Right?
Exactly. So if you say that I don't want this person to enter into my house, the zonal security guard cannot override it. So the energy associated with NIC takes precedence.
Right. Okay. Makes sense.
And I enforce these rules based on the port, the protocol, the incoming source IP address. And based on this, I can either allow or deny that request.
Right. Okay.
Yeah. So far we have seen the basic structure of a virtual network, subnets, NSGs. Okay. Now, Bhushan, I often hear about this term called a load balancer. Okay. So can you explain in terms of layman and also continuing our analogy, where does a load balancer fit in into this picture?
Right. Okay. So yeah, so load balancer, as the name itself suggests, that it is a kind of service that is balancing some sort of load. Because there is a load, there is a need to balance something, right? So continuing with the same analogy that we are talking about of the society premise. So assume that you own that house in that society that has a capacity to host, say, 50 guests, right? And then one fine day you decide to throw a party, and then you expect that, okay, probably 100 invitations are sent, so 100 people are going to show up now, but your house's capacity is 50. So what you usually do is look for some space that you can use to accommodate the additional host, right? So say, for example, you have got a friend's house that is empty because your friend is traveling probably. So you just rent that house for some time so that those 50 additional guests can be accommodated there. But then there has to be some accountability that needs to be given to someone that can ensure that, okay, if Alok's house is full, then probably that person's job is to ensure the rest of the guests that are coming up will be redirected to the friend's house, right? So that entity is essentially, in a nutshell, is a load balancer, right? Who is essentially redirecting or taking up the responsibility of redirecting the incoming traffic or people based on the availability of the resources, right? So that's what you can see in this diagram as well. The front end load balancer, as the name suggests, which is public load balancer, which is responsible for accepting public requests, which are internet bound requests, the internet based load balancer. On the extreme left that you are seeing, it is accepting all those traffic on port 80, then redirecting, distributing that based on the availability of resources to the web tier subnet, because these are different workloads located there. And then there is one internal load balancer that you also see sitting in the middle, which is internal load balancer. Why internal is because it is not facing internet directly, right? So it is only responsible for redirecting those traffic requests coming from the web tier. So you are still within your VNet, right? And then sending those to the business tier subnet. So I hope that makes it clear. Um,
Yes, that was a very clear explanation. Okay, so further moving on further, we have seen one virtual network. We have seen the structure within that one virtual network. But as we know, internet is a network of networks. It means different networks connecting with each other. So my simple question is, how do we connect two networks?
right. Okay. Yeah, of course, as you mentioned, you are definitely not going to be within one virtual network and achieve everything, because there are already different virtual networks dedicated for different purposes. And then these networks needs to talk to each other. And there are different means or ways through which you can do that. So now again, sticking to the same analogy, assume that people in your society needs to talk to or needs to go to the office, right? So office being a separate VNets, let's say, for example, it's a separate network altogether. And then these people needs to consume services from that office space, right? So that means they essentially needs to physically go there in that office premise and just use that space. Let's talk about office space as a business park. Okay. Now, how do I access that business park? So I have different ways, right? So what I can do is, if only one of the person from that society needs to access the business park services. So what he can do is, okay, he can, let's theoretically assume he can just create his own personal road and just go to the office space of the business park, right? So as you are seeing there on the highlighter, so this is that point to site, wherein one point is essentially trying to reach to the entire site, which is the business park. So /16 virtual network on the left that you see here, let's assume that as a business park, right? And then that SSTP tunnel that you see there, let's consider that as a private road that the person has created for his or her own use, right? So that's one of the way of doing it. Second is, now assume that multiple people within that society show interest that, okay, fine. So probably we also want to access those services, or we also want to use that business park. Now it is, of course, they can start creating their own roads, but then that will really not be feasible, right? So what they do is they come in a group, they create a country, they create one specific road for all of them, right? So that means on the right, you have the group of people creating their own road for their own uses. So 10 people, say, for example. So these 10 people in a group will be able to access those business park services, which is through that tunnel. That's their common shared road, which is site to site in an networking terms, wherein one site is directly able to talk to the entire site or the remote site. So that's the site to site. Of course, there are different terms and terminologies, VPN gateway and gateway. But then if you just think about gateway, what the gateway could be, right? Just a gate basically to allow the traffic to come in or come out, right? So just think about it for now. We'll talk more about that later. Now the third option. So suppose that you're not in physical networks, but then everything you have created is in virtual network within the cloud space. So what are the options there? Of course, you can still do that, like site to site connectivity, you can still establish. But then what's the use of creating that all manual effort if you are using cloud services? The cloud has to offer something, isn't it? Because it's a managed service. So there is something called as VNet peering. So what it does is it just simply creates that peering between those different virtual networks within your zone. through which you can directly establish that communication. You don't really have to do anything. You don't have to take the pain of constructing that road and things like that. So you can just configure that, and then Microsoft takes care of, say, for Microsoft Azure space, takes care of the transferring the traffic over the backbone network. So in this diagram, so VNet A, say for example, is paired with VNet B, and then VNet B is further paired with VNet C through that pairing. So it doesn't still necessarily mean that VNet A will be able to talk to VNet C directly, because these pairings are really non-transitive. So you'll still have to pair VNet A with VNet C explicitly to establish that communication. But the point is, these are not really transitive. And one more prerequisite is there, that these address spaces between these different virtual networks should not overlap with each other. Otherwise, of course, you can sense the problem here, that what it will cause, because the router will never know that where it wants to reach, right? So yeah, that's about the general concept of connecting two networks. But now again, talking this or taking this further, there is always this talk about hub and spoke architecture, which is kind of makes sense, like something as in hub and then different things are coming in as spoke. But can you just expand more on what is hub and spoke?
Yeah. So we just saw that we could connect two virtual networks or two physical networks using these different types of um methods, like point to site, site to site. Okay. Uh, Connecting two networks is simple enough. Now let's consider there are hundreds of networks and they all need to connect to each other, or they all need to consume some common resource. Okay. And they all will now start establishing peerings or establishing tunnels with each other. So that will be a whole complicated scenario, whole mess. Okay, so that's where the need for architecture comes in, or that's where the need for a pattern comes in. So hub spoke is a architectural pattern, one of these architectural patterns that is popular, and it serves a purpose. Okay, so suppose I have a city of all these different virtual networks or societies, business parks, different zones, and I, as a town planner or a city planner, uh, now suppose even let's scale out more, right? There are multiple cities, and I need to do intercity travel. Okay, so we all know that if I want to fly from Mumbai to Bangalore, I have to go to the airport if I have to fly. Okay. So that's a rule that is enforced, right? Any travel that's happening by air, the person has to go to the airport. So let's call that airport as a hub. Okay. So at that airport, I'll have to go through security. Okay. So that's how the authorities ensuring that the security rules are being followed. But
Yeah.
first you have to come to that building. Okay. So now here consider hub, central hub. Hub is basically a virtual network. Now, two spokes are connected to that hub. How? Via peering. Spokes are also virtual networks. But something is special about this hub virtual network. What is that? First of all, there are rules that the spoke virtual networks, for any uh, request they want to send, the request has to go through hub. Second special thing is that this hub has something called as a firewall. Now, this has Azure Firewall, which is a managed Azure offering. Okay.
And then, Alok, I have got a question here. How do you enforce these spoke virtual network that, hey, you want to first go to hub and
Yeah.
then you can transit from there?
Yeah.
So what helps you do that?
Yeah. So I want to basically define a rule, right? So what helps me do it is what we call as route tables.
Okay.
Or user defined routes. So the object in Azure that I want to create is called a route table, and I'll create it in associate with my spoke VNet subnet.
Okay.
So the subnet that you see here, I'll create a route table and associate that with that subnet. And that rule, moving on further, if you just focus on this route table, I'm defining here that if the destination is this particular address basically represents internet. So if this spoke wants to send a request anywhere in the internet, what's the next hop? I want it to go to this particular IP address. This IP address is the private IP of this firewall. So firewall is a device which has an IP address. So I am saying your next immediate hop should be that firewall.
All right. So this is that airport.
This is that airport.
Okay.
Yeah. So this any request going from this subnet has to follow these rules. Similarly, the second rule is that if you want to go to this, if you want to go to any IP from this range, the next hop is your firewall.
Right. So this is where you are establishing the spoke to spoke communication.
Exactly. So that range is of this VNet. If this VNet wants to talk to this VNet A to B, it cannot go directly. It has to go through the hub.
Right. Okay. So then you can clearly see the value that A, you can have the central mechanism to enforce the security rules and also enforce these different policies that you want to apply without even worrying about repeatedly applying those policies to different spokes. You can manage that centrally, makes admin's job pretty easy. And then second is the route tables concept that you explained, which essentially takes care of routing the traffic as the name suggests, right? Okay.
Exactly. Yeah. And then this firewall itself has it's an Azure offering. It's a managed offering. So it has its own features like threat intelligence. It will automatically block known malicious IP. It will be highly scalable, highly available. Yeah. In this diagram, you can see that there are further connections going on from the hub. And we have already seen what site to site is. We will now see what ExpressRoute is. But basically, these connections are going on to other on-prem networks, or which are also spokes.
Correct.
So if this spoke wants to talk to those remote networks, it has to go through the hub. We can see that two different ways of connection are shown here. Site to site we have already seen, but what is this express route, Bhushan? Can you elaborate on that?
Okay. So now, as you mentioned, so you have two ways to reach to the remote network now. So site to site we have seen, which is in terms of that road example that we have seen. Express route is something different. As the name suggests, it's an express route, kind of an express highway, right? So basically it's a leased line that you own, that you only own. No one else is able to use that. It's a high-speed connectivity line. Now let's simplify that further. So say, for example, even in the previous diagram, so two modes of traveling, right? So because we are talking of an airport, so from airport, what you can do is you can take the commercial flight, right? That will still take you to the destination, but it will take its own time, right? Whatever is the destination time. But then you can also own your private jet that will take you only to that remote destination with maximum speed and minimum time. So that's that express route concept there. So you can just own that and for self-use with the high speed capacity. And then it has all these different features like resiliency and redundancy and things like that. But we can talk more about that as we go along.
Yeah.
Now, in sites of the express route, basically what it consists of. So as I said, it is basically a connection between two different endpoints. So it's a route, it's a line that I talked about, right? So when we speak of any line, it has two ends. One end, in this case, basically terminates in your remote network, which is your own customer's network, right? And then the other end terminates in the Azure, right? So whatever you see in between, this space, which is partner edge, Microsoft edge, is that shared infrastructure or the common infrastructure that your provider brings. Okay, remember the term that I use that you have to purchase this. It's a lease line for you. So someone has to sell that, isn't it? So who is that someone? That's an ISP that usually sells these lines to you. So in our case, it could be Tata, say for example, or it could be Airtel, through which you can outsource these lines, right? You can purchase these lines. What they essentially do is they give you some sort of setup through which you can establish this connection. So now partner edge that you see, these are the set of routers basically that the partner brings or the vendor or the provider brings. So say, for example, it's Airtel routers. They are sitting there in that common building. And then Microsoft Edge is wherein Microsoft brings their own routers and then makes them sit in front of those partners routers. And then you connect, essentially make these connection. Whose onus is to make this connection is that provider. So Tata or Airtel, say for example, is responsible for ensuring that these routers are connected to each other. So the lines that you see, and that's the resiliency part that I was highlighting about the primary and secondary connection. So it's implicitly inherently there. Even if the primary connection goes down, so it's an onus on the provider to ensure that all the connections switches to the secondary connection, and then you get that high availability or resiliency, even with the one point of presence. I'll talk more about what is point of presence later. Now you see this different coloring code there, so red and blue. So what is that? There are two different things on the Microsoft side, right? So Microsoft has its own set of public IP ranges through which Microsoft broadcasts its own SaaS services. So it could be Office products, it could be Teams, or it could be OneNote and things like that. And then you have your own virtual network, that what we have been talking about, that you want to only broadcast or advertise those addresses and then talk to those workloads privately. So that's the blue line representation. So what that means is each router provides you two modes of connectivity, and that's what the concept of the peering here. If you see those points on the left on this deck, just private peering, Microsoft peering. The public peering used to be there. It has been deprecated now. So as the name suggests, Microsoft peering. So it is a peering, basically a connection that you use to talk to these public services over public IP addresses. And then the private peering is something that you establish to advertise or only for your own workloads with those private IP addresses that delegate from your virtual network, right? So that's the overall setup and fundamentals of ExpressRoute, how this really works. Um, but then there is more to that. How essentially ExpressRoute talk or how they can communicate to these on premises network using some sort of protocols is something I think I'll hand it over to Alok to explain more about that. What essentially it makes use of.
Yeah, very well explained, Bhushan. So basically, we have a private jet to connect our Azure virtual network to our on-prem network. It's more expensive, but it's your own private jet. It's faster, it's more resilient. And as Bhushan said, there is a common point of presence which has partners, routers, Microsoft routers, and they are connected. Okay. ExpressRoute in the background uses a routing protocol, which we'll take a look at next, which is called Border Gateway Protocol, BGP. Okay. Now, BGP happens to also be the protocol that internet uses to make different networks aware of the routes that it's aware of, right? So it's important to look at it because it will be useful when we see our scenarios further. So what is this protocol? Basically, it's used to exchange routing information which different autonomous systems. Now, what are autonomous systems? Just networks with single administrative control. Basically, any network, it can be an ISP, it can be a company's own network, okay? It can be any content provider, a single independent network.
Right. So if you look at it from the lens at the top 500 feet, so you get your line from Airtel at your home. So say for example, right? But then that connection, Airtel should also be taking some sort of connection from someone to give you that line, right? So that someone would also have their own network,
Yeah.
and then they are also probably taking the connection from someone.
Yes.
So it's a chain of providers,
Yeah.
right? As you go top.
Yeah.
So is it safe to say that these are network of networks and then these are at very high level? So say for example, Airtel. So one of the cloud that is represented here could be Airtel. The other cloud could be Tata. The other cloud could be Geo, say for example.
Exactly. So our autonomous system is at that high level, and those high level networks are exchanging routing information with each other as soon as they become aware of it. Now, what is routing information? Just the fact that there is this IP that I'm aware of. There is this IP address that I'm aware of, and to go to this, you have to hop on to this next appliance. Okay. Here you can see. Let's consider an example in this particular diagram. I have my AS65004. That's autonomous system and a number. So
That has to be unique, I think, for every network or the
it has to be.
globally.
It has to be, yeah. So that's ASN or autonomous system number. Now for this AS to talk to 65003, how many paths are available? There are three paths available. One is like this, one is direct, and one is via this AS. Okay, so three paths are available. BGP will make this AS aware of all three paths. Now this protocol decides what's the best path, and that is based on the length, and that is based on the local preference, which is a setting which we can set. Okay, so if we just see the shortest path, it will directly go, which in which the next hop is directly the destination.
Right. So it prefers to take the shortcuts.
Yes,
Okay.
exactly. So that's border gateway protocol in simple terms, which ExpressRoute uses. And we'll see in more detail how it uses it.
Right. Yeah. But then still makes me question what is that need that ExpressRoute only should be making use of BGP and not something else?
Yeah.
I think the easiest answer to that is because ExpressRoute has the capability to get you connected to anywhere in the world, right? So it's essentially has to traverse or make use of the internet, and that's the probably only advanced protocol that it has available with us. That only BGP probably makes these connectivity and the connections faster and easier. So that's why it relies on the BGP as such by default.
Yes,
Right.
that makes complete sense. Yeah.
Okay.
Now, I think we should bring together all the concepts that we have learned till now, right? Like hub spoke architecture, express route. How would we represent our hub spoke architecture in which there is an on-prem network which is connected to our hub via express route? So let's look at this diagram that we have. Okay. There is a hub which we have already seen the function of it. It has a firewall. It has a spoke which is paired to it in Azure. Now this here is an on-prem network, okay, which is also a spoke. It's connected to the hub via express route, but this new component has showed up here. What is this? This is a VPN gateway. A gateway has to be in place. Uh, Gateway is nothing but a gate, as Bhushan said, right? To allow networks in and out of a request in and out of a network. This VPN gateway has to be created in our hub, and it will have an own separate gateway subnet, which has to be created for a gateway. Uh, so that's a rule enforced by Azure.
And again, why that rule is enforced is because you definitely want to have this gateway provision its own subnet that is usually is either /27 or /26. Why that is because its VPN gateway is a managed service. In the back, it will of course be running on some sort of compute that someone is hosting for you and configuring it. So if you have enough addresses available, so even in case of scale up scenarios, so you should have those address spaces available to accommodate the additional instances on which the VPN gateway will be configured and created. Always have this created on /26 or 27 as a golden rule.
Yeah.
But yeah, that's the primary intent of having its provision its own subnet.
Yeah, and while we're on it, the Azure Firewall also has its own subnet which has to be created, because in the back end it will provision its own devices that we are not aware of, and
the managed instance or the managed service.
Yeah, and those will go in that subnet. The gateway only comes in picture with point to site to site, and express route. It doesn't come in picture with a simple peering.
Because peering is again a managed service, so someone is doing that for you.
Exactly. Okay. Now, in this particular part of the diagram, we are basically seeing a miniature version of the earlier diagram wherein there was a partner edge, there was a Microsoft edge, there were two connections which were redundant. In the green arrow, you can see this is nothing but the line going from your on-prem network to the point of presence. Consider this box as a point of presence, a common building, which will have your partner routers and Microsoft routers.
As we saw, yeah.
And the magic happens there. Okay. And the blue line is your Microsoft routers taking the line up to the cloud. Okay. You can also see that there is something called as connection weight 100. What is a connection, first of all? As you can see, connection is nothing but an object in Azure that we have to create to establish the connection between this gateway and this express route. Okay. Simply provisioning the express route in Azure is not enough. We have to create a connection. Okay, connection is nothing but an object which takes two inputs, your VPN gateway and your express route. Okay. What's a connection weight? Okay. Connection weight comes into picture when there are multiple connections. Right now, there is only one connection. It has a weight of 100. It doesn't matter if it was 90 or 80. But as we will move further, we'll see with multiple connections, the weight is nothing but a priority number that comes into picture. Okay. Now, you can also see this icon and which points to a table. Okay, we have already seen what this is. This is nothing but a route table. Okay. Till now, we have seen what a VPN gateway is, what a connection is, what a routing weight is. But there's a fourth point called route advertisements. Okay. What is route advertisements? We have to make ExpressRoute aware of certain route. In BGP, we already see that different systems make each other aware of different routes. That's the same thing that we are doing here.
Then why that is required, Alok, if you can highlight that as well.
Yes. So, you see that's required because we want the on-prem network to be aware of this spoke.
Right. So it needs to talk to that spoke.
Exactly. Your workload is in this spoke. It can be anything. Your hub is only concerned with connectivity and security.
Right.
So your application, your workload lies in your spoke.
Correct.
Now you see there is no direct connection with the on-prem and the spoke.
Yeah.
So the request will originate from your on-prem, but it needs to be aware of where to go next.
Correct.
So you see the destination is the spoke's address space. The next hop is the firewall's IP.
What we are asking here is, hey, on-premise traffic, if you want to reach to that 10.0.0.0/16, any IP from that address range, so you should use that next hop, which is the IP of your Azure firewall, as a next hop to hop on, and then firewall should decide that, okay, I'll redirect that traffic to the spoke now.
Yes. Yes. Okay. The firewall being a virtual appliance, it can not only just inspect traffic, it can also route the traffic further. So as soon as it gets a request and the destination is the spoke, it will say, okay, I am aware of this spoke because I am directly paired with that spoke. Right. So let me just forward it to the destination.
And then again, you can still define some sort of security rules or policies that, okay, so if on-prem application is accessing this particular IP from this particular port, then I'll not allow, but I'll only allow requests coming from port etc, for example, and then I'll only transfer those. So you can do that magic in that firewall box.
Exactly. Right? Okay. Yes, you can do that. And just wanted to highlight that as soon as we associate this route table with this subnet, which is the gateway subnet, the BGP magic starts coming into picture, and this express route is becomes aware of this route,
which is usually called as route advertisements then, because you're actually advertising that range of your spoke VNet to your on-premises so that it is aware of it.
Yes, right? Okay. Yes. That's a route advertisement.
I think we can move on with that understanding.
With this understanding in picture, we have to now move on to a scenario where there is a global company that I have, and my company has multiple hub networks, and they're in different regions.
Right. So before we even go to the regions, just wanted to, I think, make one point clear that the POP location that you talked about, it's not really the Azure region, isn't it? It's a different region or the location that your ISP owns, because it's a kind of a physical building in a layman's term.
Yeah.
So that building could be in Pune, right? While your Azure region could be Mumbai or Central India. So um, even before going there, I think the need of having two regional deployments. So why usually people do that?
That is done for region redundancy.
Okay.
First of all, and the second region could be the second reason for that could be uh, high availability.
Right.
Okay.
So to protect basically from any regional failures that you have in primary region. So even if now with this diagram, so if we say VNet A is in Central India, and then VNet B is in West India or Southeast Asia or any different region of Azure. So if the entire region of Azure goes down, then probably you can hop on to the next region, given that you do that failover. And then you have also two express routes that are shown here, which is created in one POP location, other is created in a different POP location.
Yeah.
Okay.
Yeah. So it's important to again highlight that this location is different from Azure's regions,
Right.
that we have. And you have, while provisioning express route, you have to choose the POP location of an express route, which makes sense for your Azure region.
Right.
Or which is closest to your Azure region.
Ideally, it should be closest, right? Because you don't want to introduce any further latency.
Exactly. Yeah. Now see, there are two hubs and they are in different Azure regions that I have for data redundancy purposes or of disaster recovery or failover purposes. Okay. I want to connect my on-prem network with both these hubs via ExpressRoute, which I have done. Okay. But now see, there is a drawback in this kind of a scenario wherein I am dependent on my ExpressRoute's POP location.
Right.
Suppose in the case that this point of presence location, which is essentially a building, fails or stops working for some reason, my this connection is cut off. I am cut off from my Azure region A as far as on-prem is concerned.
Right.
I am only connected with my region B. Okay.
It's still a rare scenario though, because even if we are talking of a scenario when POP location is going down, wherein we saw that already you get the resiliency in the POP location in terms of primary and secondary lines that we saw in that diagram. So what we are saying here is both of the lines go down, or it could be a catastrophic failure for some reason that entire building goes down. So that means no line is active. Exactly. So it's that scenario.
It is that scenario. And also you see, while we're on this, let's focus on these route tables as well that we have associated. We are making the express route aware of this hub's address space, but imagine there's a spoke and we can add that entry to this route table as well as we saw earlier.
Right.
So in routes advertised, there's just 10.2. This express route is not aware of 10.3.
Correct.
Similarly, in this express route, it's only aware of 10.3. It's not aware of 10.2. So, Bhushan, suppose I want to prevent against the catastrophic failure of the point of presence of express route, and I want to somehow magically use, in case of this express route fails, I want to use this express route to connect to this region.
Right.
How can I do that, or what kind of architecture would we apply in that case?
Right. No, I think you are right. And that's a fair assumption to go with, because you never know. You already want to prepare for worst, and you still should have some sort of provision there so that your workloads are at least accessible and learning. So as you mentioned, so the idea here is that you originate the connections from either of the express routes and then make them terminate in the across the region. So what you were highlighting earlier is this, that POP location should originate a one connection, should terminate in the region B, and then vice versa.
Oh.
So there is this pattern that is coming over, and we'll talk more about that, the value that it brings or the cons of it as well as we go along. But then, yeah, you're right. It's just about creating those cross connections.
Okay, so you are saying that even with one express route, I can create multiple connections.
Yes, you can.
With that terminate in different VPN gateways.
Yes, you can.
Oh, okay.
And then that's what the next slide talks about is usually this pattern is called as bow tie architecture. As you can see, as the name says, it looks kind of a bow tie, wherein you are now seeing that we have also brought in the spokes at the top in those two different regions. So you have on the left, which is spoke of your region A, which is the regional hub, and then spoke B, which is the spoke of the hub B in the region B, right? And we have these different connections. Now, those are clear, of course. And then there is this route table associated as well. So nothing changes apart from those connections. But then as you can now see that the connection coming from the express route 1 is also going, the second connection is going to the region B gateway, and then same here as well. So now imagine that the spoke in VM A or VNet A needs to talk to on-premise, right? What are the paths available here? So we have two paths available here in this case, right? In a happy path scenario. So you can also come in via express route 1, and then you can also come in via express route 2. Now, that's when the importance of the connection weight that Alok was referring earlier comes into picture. That how Azure chooses the connection to reach to on-premise. It will always choose the connection with the higher weight. So weight 100 will be chosen there. So it will still ignore that weight 90 and then will pass on the traffic through that weight 100. Now assume that the scenario why we created this. So express route 1 pop location going down, right? So entire building goes down for some reason. So on-premise traffic is still able to talk to your spoke A in VNet A to that connection. Now that will take precedent because the weight connection with 100 is no more available. So you have to rely on 90. So Azure will make use of that connection with weight 90 to reach on-prem. And then the vice versa. If Express Route 2 goes down, it will pass the traffic via Express Route 1 via that 190 connections. Okay. Now let's talk about the advertisements here as well. So as you can guess, or you might have guessed already. So there are duplicates routes being advertised. So far, what we have seen and talked about is the traffic coming or originating in Azure, reaching to on-prem. But then what about the traffic that originates from on-prem and needs to go to Azure, right? Because of these duplicate routes. So Alok, do you want to take over and explain how do you want to do this?
Yes. So from on-prem to Azure, the connection weights that are there won't come into picture. Okay. The connection weights is a Azure specific settings that is looked at when we look at the traffic that's coming from Azure to on-prem.
Right.
Okay. But now I want to reach, suppose I want to reach my spoke A from my on-prem and I have two routes available for me. Okay. One is this, one is this. So now let's remember that BGP is at play here. Okay. And we already saw that BGP chooses the shortest path based on the protocol. Okay. So in a happy path scenario, I have two paths, but as you can see, this will be a longer path, first of all, or will it be?
Yeah, it will be a longer path because when the way advertisements happen, because if you again stitch all this together with the explanation that we have seen earlier, so there is this concept of advertisements. So the when Express Route 1 starts advertising the spoke VNet, which is 10.0.0.0/16, which is your spoke A, when it starts advertising that, it advertises it on the shortest path. Express 2 also advertises that, but then it will advertise that on the longest path to on-prem. So because BGP is in play here and on-prem is aware of that, so on-prem is always going to prefer the traffic over the shortest path. Given that you have configured your on-premise side to do the route preferencing, because of course on-prem needs to be aware that okay, it has to do the route preferencing so that it starts choosing the path which is advertised on the shortest path.
Yes. So that route preferencing, you are referring to the local preference setting in BGP?
Correct, exactly. And then it is always a onus on on-premises side to ensure that it has the capability to do it.
Yeah.
This is again based on the one of the learning that we had, wherein we had to implement this, but then the on-prem did not really have the provision to do the local preferencing.
Yeah.
And then in that case, it really creates the problem because from an Azure sense, if the traffic is leaving Azure, then the connection weight comes into picture. But then for the reverse traffic, Azure really can't do much here.
Yeah.
It has to be done through the customer's premise or the ISP or the vendor that whatever is taking care of your on-premise network.
Yeah. So let's to summarize it all, consider two scenarios. One is happy path, and one is that express route goes down. And what routes are chosen, what path is chosen by both uh, both ways of traffic. So I want to reach my spoke A. This express route is up. I have my local preference setting set to, if you want to reach this IP address, use this express route. In that
Correct.
case, I'll go via this express route and I'll reach. Now that same request has to come back. It will come back. It will see there are two connections. One is 100, one is 90. It will choose the 100 and it will come back. So it's symmetric routing and it works with the
Right.
shortest path.
Correct. And ideally, it has to be the state in. There is no harm that even if the traffic comes via the express route too, but then that will give that will invite basically asymmetric traffic. And then there are certain times when you don't want to do that because of the latency requirements that you have that any traffic should come
Exactly.
within these milliseconds and things like that. So you should always probably try and achieve the symmetric routing.
So an example of asymmetric routing would be if on-prem chooses this express route to go to my spoke. While coming back, Azure will always choose this connection,
Correct.
which is 100. So while the request is being sent, it goes via this path, but it comes back via this path. This is called asymmetric routing, and this can cause some inconsistencies in your networking behavior.
Correct.
Or cause some latency also. So that's what we want to avoid.
Exactly. Yeah, that's the whole point.
Exactly. Yeah. Okay. Now let's consider this express route goes down. Okay. So that this express route, this path is not an option for us. Correct. To go from on-prem. We'll go via this route naturally.
Yeah.
We'll go to the spoke.
Yeah.
While coming back, Azure will identify that this connection is down. It has only one connection available to it, which has the weight 90. So it will come back via this path. So that's symmetric, and that works in case of a in case of an event where express route pop location goes down.
Yeah. Yeah. Cool.
Yeah, I think that pretty much sums up our learnings of what we wanted to share. So for our viewers, if you have any questions, we are ready to take on those. Hope you had some fun learnings.
There's already a question from Rohan on the chat in the Q&A.
You might want to read that out, Aishwarya. Can't see it.
Okay. Okay. So it's a long one. So his question is just trying to understand what a tunnel means in the context of P2S/S2S. Does it mean that the client machine or network get a dedicated space in the cloud provider's backbone network? Or does it mean that the traffic is like encrypted but is still flowing over the internet till it reaches the private network's entry point? And how
Right.
would that be different than HTTPS if that's the case?
So HTTPS is usually for your web traffic, where the name suggests it's a HTTPS protocol. But then in case of the tunnels, so tunnel consider that as a channel or the pipe that you establish between your own network and the Azure workloads or the Azure VNet. Of course, the traffic is still flowing over the internet, but then there are different ways to secure that traffic. So you can do the certificate-based encryption, or you can use some other protocol to do that. But then, in a nutshell, just as understand that it's still flowing over the internet, but then over some sort of encryption. So it's an encrypted channel that you establish between your own network. So there is no backbone network asset that comes into picture because it's something that you have created. So in case of point to site VPN, so there is this concept of VPN client that you have to install on your machine. So while you install that, it asks you to do certain configurations. So like I said, it could be providing the certificate key, or could be entering your Azure AD credentials in case of the protocol that you're using, which is OpenVPN. So that supports Azure AD authentication as well. And then same is applicable for site to site as well. So I hope this answers your question.
Yeah. Are there any other questions?
No, it's only that one. If Sadhguru has a question.
Hi guys, thank you very much. It was a wonderful session. So there is a one suggestion I would like to ask you guys is, like, let's say with the load balancer stuff, when you were explaining a lot of stuff, it was very helpful to me. I need a one suggestion, like, what if we don't have to go with the HTTP connections, we only have to have a HTTPS connections over a secure channel, and how we can attain this with the load balancer, and what is the best um way to get into it? Is it if you can put on some insights over it?
Right. Okay. Now that's a good question. See, there are different load balancing services, and again, these are based on the different layers at which the service operates. So if you specifically talk about the load balancer, which is a layer 4 service, which is you have to specify your ports and the destination and things like that in the configuration, which is required on the networking layer. For web traffic, usually there are different services available. So it could be your ideal services. You can still do that using load balancer, no harm. But then if you really want to harness the power of those different services and the value that they bring in, so it could be application gateway that operates on layer 7. And then you can do these different configurations. If you want to terminate that SSL on the application gateway front itself, so that the load of decrypting that traffic is taken care by the application gateway, and then application gateway reaches out to your backend pools wherever your application is hosted via the direct trust connection that you can establish. So that means the web servers won't have to take the load of decrypting that traffic and then spend compute on that. So you can do that SSL offloading there and there on application gateway itself, and then redirect that traffic directly to the web or roles. Anything else that you want to add, Alok?
No, I think you pretty much summed it up. Load balancer is a network layer device, and application gateway is wherein the protocol comes into picture. We're going to enforce the rules regarding the HTTP or HTTPS protocol.
I hope, Sadhguru, that answers your question. Or feel free
Yeah,
to ask.
very well,
anything else.
very well. Thank you very much.
Subodh is typing something. Yeah. In a hub, Subodh's question, in a hub spoke setup, is it always necessary to manage the route tables, or Azure has a service for the same?
Right. So in an ideal world, why you would set the hub and spoke architecture is basically to manage some sort of central, or to gain some sort of central control using the hub, wherein you would want to ensure that all the spoke traffic is first sent to hub, and then hub does its own magic before it transits that traffic to further remote networks. So you usually do that. It's not a thumb rule as such, but then still many of the cases, or most of the cases that I have worked with, you usually introduce the custom route table on the spoke networks, or even for the hub networks to advertise those specific routes. So you have to probably make use of that. When you peer two different virtual networks, there is definitely something that Microsoft brings for you, which is the system managed routes that are in the route table, that so that all the subnets within that virtual network can talk to each other. But then if you want to really override that behavior to gain more control, that okay, only specific subnet should be able to reach hub, and then hub should be able to transit that further. In that cases, you usually introduce the route tables. Recently, Microsoft also has introduce this service wherein you can centrally manage these different routes in terms of a route table as a service. So the router, I think some sort of name, I can't recall it now. But it's a managed service where you can maintain all your routing information and then reuse that or reapply that So you won't have to maintain different route tables individually at different subnets. Does that answer your question, Subbu? Thanks, Subbu.
Okay, I think with that we can conclude our session. Hope you enjoyed it, and if there are any more questions or just general discussions, you all can reach out to me or Bhushan. We would love to talk to you.
Yep. Thank you, everyone. Thanks for joining us on the weekend.
Thank you.
Thank you,
Thank
everyone.
you.
Thanks,
Thank you,
Alok. Thanks,
Alok.
Bhushan.
Thank you,
It was a great
Pankaj.
session.
It's a great session.